So hi guys, good morning. Thanks for joining. So as I mentioned earlier, we will be starting the uh, two of the projects in terms of running your Terraform pipeline and provision the resource in AWS, and the other project is CI/CD pipeline to deploy to Kubernetes. So before we start those two projects, one should know about the runners. So runners basically help us to execute or run our jobs on the virtual machines or uh, small weight containers or pods. So we can run our jobs either in the physical EC2 instance or Kubernetes cluster where we have to provision the pods. So in GitHub especially, so there are two types of runners. One is self-hosted. So the other type of runner is um, hosted runners. This is managed by sorry. So the hosted runners are managed by GitHub, and the self-hosted runners we have to manage is managed by you. So let's talk about the differences between these two. So the first one is let's talk about the hosted runners. So where we have like GitHub will manage for you. So the supported types for the hosted runners are so we like GitHub will support Windows, Linux, and macOS. So by default, if you are like running multiple jobs inside a single workflow, so the auto scaling will happen automatically. So when it comes to the maintenance, so hosted runners will be handled by the GitHub. So whenever you try to create a fresh job, so whenever you try to create a fresh job, if you are opted for the hosted runners, so GitHub will always create a fresh VM for each job. It will always create a fresh VM for each job. So when it comes to the cost, if you are using hosted runners, it will be included in GitHub plan, where it will calculate the amount based on the minutes. So this is all about the hosted runners. When it comes to the self-hosted runners, which is like in the real-time projects, we use only the self-hosted runners. We don't use the GitHub hosted runners because if you use the GitHub hosted runners, they will simply provide the plain VM. So it doesn't contain any softwares required for your applications to build. We have to install everything on our own as part of the workflow. So if you start integrating all the required steps uh, to run your software to build your application, so the application build time will basically increases, right? So, because every time you use hosted runners, it will always give a fresh VM. So if they provide the fresh VM, as part of the workflow, we have to integrate all the, we have to define all the required tools installed on the VM on the fresh VM. So if VM is terminated, so if you rerun the job again it will create a new VM. So again, you have to install the required tools. So if you are like integrating all the required tools installation, the build CI/CD process will gets delayed. It will increase the time, which developers they don't agree. So they want the pipeline to deploy as soon as possible without any external dependencies. So as a DevOps engineers, we need to propose that all the external softwares we need to configure like earlier so that the application deployment will go smoothly without installing any other software. So that's where we use self-hosted runners. So self-hosted runners, it is managed by us or you. Okay, and any OS GitHub Actions supports, like you can have the self-hosted runners for Linux or Windows. So Linux, if you are using Linux, so you can use workflows to deploy to the Linux servers. Most of the runners that we configure is mostly on Linux-based runners. So, but scenarios like if you have your application that you need to deal with the Windows EC2 instance. So scenarios like that, we use runners as Windows because for the Windows EC2 instance, we have to use PowerShell or command prompt commands, right? Linux commands by default, it won't support. So we need to do some kind of configurations, which is like headache. So that's why they use Windows-based runners. What happens whenever you execute your job and you point the runner as Windows, so the Windows VM will or pod will create for you, which is purely Windows based. And from Windows runners, you can talk to the Windows servers whenever you can execute the job, different commands, PowerShell scripts, all those. So depending upon the use cases, someone will use either Linux or Windows. So in my project, we use both Linux and Windows. So Linux, we used most of the deployments like ECS, auto scaling, and also we use for Lambda. Everything is Linux-based runners. And for the Windows, I have used recently for one of the project. So like where I have migrated um, the pipelines or they have created a pipeline to deploy to the Windows server. So they have like doing the deployment of moving the artifacts to the EC2 Windows instance manually. So like I have been tasked to automate that to move the artifacts to the target location in Windows. So as a like enterprise organization in my project, we have the runners created by a separate team, which we called as edge services team. But in some companies, DevOps engineers will configure everything. But in my project, because we deal with like our project will have multiple projects inside. So managing all the runners is pretty risky one. So that's why they have like we have a managed services team where they will configure the runners. We just use those runners. So those runners we have Linux and Windows. For the Windows, I used for one of my tasks to move the artifacts to the Windows section, Windows machine, and also there are some couple of scripts that developers given to me, and those scripts I have to move to the specific location in the Windows and then trigger the script. So scenarios like that, I have used Windows learners. So when it comes to the auto scaling, it is managed by us, and then we need to configure uh, auto scaling by us because there are two types of auto scaling. If you are like running, configuring your runners or Windows EC2 instance, so we have to configure the EC2 instance auto scaling. If you are using EKS, so you need to configure the auto scaling in the EKS, like by using horizontal or vertical auto scaling concepts. So, and it's also when it comes to the maintenance, we need to handle updates. For example, any patching we need to do, the OS upgrades, we need to update, we need to handle the updates. So which is like when it comes to if you are using the runners, ECD based instance, ECD based runners, we have to manage everything. And if you're using Kubernetes managed runners, so Kubernetes cluster maintenance, upgrades, and also anything that you need to configure. So everything we need to manage manually because we are hosting the self-hosted runners. And when it comes to the cost, so it is free for runners software. And the only thing we have to like we pay is you pay only for infrastructure that you used. For example, if you have provisioned EC2 instance, whatever the time that you used your runner, you have to pay. So, but if you're using EC2 instance, the problem is always you have to pay for the ideal cost as well. But when it comes to the EKS, the runners will provision only when you trigger a workflow. So EKS will have the advantage. Anyway, I'll show you the documentations in the for the self-hosted runners. So many organizations used some concept called ARC, which is Actions Runner Controller. So you have to deploy this ARC using Helm charts or kubectl command on the Kubernetes cluster. So once you deploy this ARC, so it will create a runner group. So runner group is basically where you isolate the runners, like group A, group B, group C. And the runner groups will also have something called labels. So labels we attach to the runners. For example, so you can create a label for build runner. You can create a label for deploy runner. So just we have to differentiate because you understand. So if you are using runner for the building your application, so you require all the softwares like the build tools like Maven and everything. Do we really require those during our deployment? No, during the deployment we just need to the artifacts, right? So at least if you are using for deployment help, like if you are doing deployment for using build runner, at least some amount of time will consumed because of the prerequisites installed in the runner. So what if you decouple these two, build and deploy? The deploy will only deploy the deployment related steps and build will do only the build related steps. So if you decouple those, at least you can decrease the CI/CD pipeline runtime. So that's why in organizations, they always use build and deploy runners. So they use labels to differentiate those runners. So these concepts will be like available in the self-hosted runner. You are using EC2 instance, and this is also used concept used in the ARC action runner controller in EKS to deploy in EKS. So in today's demo, we will be setting up the self-hosted runner on the EC2 instance. And ARC, I'll show you the documentation how it looks because ARC configuration is little tough. So for this course, it is not part of the uh, plan. So if I do any further video, I'll make a video and I'll upload to the our group and update you guys. So let's create a self-hosted runner first on the EC2 instance.
Curious.
So yeah.
ఇది మనకు గిటాబ్ రన్నర్స్ లో ఎవ్రీ జాబ్ కి ఫ్రెష్ విఎం వస్తుంది కదా, అంటే క్రియేట్ అవుతుంది కదా
Yes.
డెస్ట్రాయర్. అండ్
Yeah.
సెల్ఫ్ హోస్టర్ లో మనం ఒక సపరేట్ EC2 ఇన్స్టాన్స్ క్రియేట్ చేస్తాం. సో దానికి దీనికి ఓకే మీరు తేడా చెప్పారు, బట్ ఇక్కడ మనం ఓన్లీ సెల్ఫ్ హోస్టర్ లో ఆ ఒక్క ఇన్స్టాన్స్ ని యూజ్ చేస్తాం కదా రన్నర్ గా. సో మనకి ఇప్పుడు జాబ్స్ పెరిగే కొద్దీ ప్రాబ్లం అవుతుందా, అంటే ఇప్పుడు అక్కడ
Yes,
టెస్ట్.
yes. If you are using one runner, one EC2 instance, then it is like the runner. If you have too many jobs, if too many developers triggered the job, the runner will go into stuck state or pending state because it can't handle too many requests. So that's why you have to configure auto scaling as part of the runner. If you are using EC2 based runners, you have to configure, you have to place your EC2 instance in an auto scaling group.
బట్ ఇక్కడ గిటబ్ రన్నర్స్ లో కూడా ఒక్కటే విఎం యూజ్ చేయొచ్చు కదా అక్కడ. అంటే వాట్ ఈస్ ద మెయిన్ రీజన్ బిహైండ్ క్రియేటింగ్ ఎవ్రీ టైమ్?
For the self-hosted runner you're talking. So only difference is, see, only difference is that if you are using self-hosted runners, so you have your EC2 instance on your hand. So whenever you have the EC2 instance, so you can install the prerequisites. For example, Maven build tool, Gradle, or if you are using any other build tools, or .NET Core, you can install predefined, or you can, like during the runner provision itself, you can use the user script to provision your, I mean, to deploy your build tools. Or you can use Ansible playbooks. As soon as the runner is provisioning, you can trigger that script to install the prerequisites. So you got the point. So during the runner provision time, you can install all these required softwares so that your application workflow, CI/CD pipeline workflow will have only the required steps for the application to build and deploy. You don't specifically mention the installation steps. That will take time. If you have all runner, self-hosted runner, which is like ready for consume, so that will take, I mean, saves us a lot of time. So that's the only reason we go for self-hosted runners. Because GitHub hosted runners, we don't have control. You can't access it into GitHub hosted runners. So we have for sure define all the installation steps on the workflow. So and your workflow length, like the number of lines will increase. So and also that like whenever like each step is executed, we have to install all those steps, which will take time. In some softwares will require some minutes, right? Developers can't wait until everything is installed. They don't have like that much patience. Like even they have patience, that is not a best practice if you think from a DevOps perspective.
ఓకే సార్.
Yeah. So can you guys see my screen? AWS account.
ఎస్.
Okay. Yeah. So first I'll create a EC2 instance. So I'm naming it as the host runner. So I'm using bare Ubuntu machine. So then I'm using c2.medium, keep which I already have security group and then provisioning instance. So meanwhile, let's go to GitHub. Right now I'm in my GitHub. So if you go inside the organization, so there are two places where you can see like the number of runners that configured in your organization. So if you go to settings and go to actions, you will see a runner section. So here you can see the runners that are configured at the organization level. So if you configure runners at the organization level, whoever part of, I mean, whoever created repository in this organization can make use of these runners. Or else, if you want to configure runners only to the specific repository, you can go to the repository settings and go to actions. And then you see the runner section, you can configure these runners. If you go to the another repository, like yesterday I was doing some configurations. For example, for this repository, if you go to the runners and if you go to the actions, go to runners. See, yesterday I was playing, like I have configured these two runners. Like this runner, like this name of the runner, which is like IP address, the private IP address of the EC2 instance. You can also change this name. I'll show you that how. And these are all the labels. So these labels you basically define in our workflow. So if you define any of the like what label as self-hosted in your workflow, so like this runner will have, consumed, like identified that runner and executive steps. And also the runner status will have like three status. One is offline and the other is like online. The other status type is ideal. So if the runner status type is ideal, which means there are no jobs executed, which is like ideal, the runner is ideal. So if the status is online, which means like some of the, like someone triggered the job and it is ready to take that job, take that workflow trigger. So let's remove this in order to just clear the stuff and have the fresh runners configured. So I'm just removing this too. So for now, I'm configuring the runner at the repository. So the way how to configure the runner is there are like some predefined steps that you need to execute. So those steps will be provided by GitHub. You just have to click on new self-hosted runners. And then if you scroll down, you will see the runner image. So like I was talking in the previous at the beginning, so you can have like Mac OS based, Linux based, Windows based. So I'm selecting the Linux based. So these are the steps that you need to perform on the runner, where they like you need to configure the like required configurations details for the EC2 instance to talk to the GitHub. So let's like, for example, if you see this step, so it will provide us as a token that you need to configure, you need to run this on the runner. So let's run this, but before that, let's connect to the EC2 instance. So let's go to click on connect. Okay. So trying to connect to the EC2 instance. So yeah, I've connected to the EC2 instance. So let's execute these steps one by one. So first I'm trying to configure a folder. Going inside the folder. And then I'm running the package, runner package basically. And then doing some validation. Going tar to unzip the files. And then you see, like I'm configuring the GitHub, like I was talking about the runner groups. So if you are not providing any runner group, it will like the default runner group that GitHub will use the default one. So you can give it as a name, but now I'm not giving anything. And then next is like is asking for the name of it. If you are if you are using the name of the runner, it will show you in the GitHub URL. So if you are not giving any runner name, it will use the IP of your EC2 instance. So I'm not giving anything. I'm just using the IP EC2 instance, my private IP. And then when it comes to the the third step, it will ask for the labels. So if you're not giving any labels, it will use self-hosted runners, or you can use your own label. For example, you can use your project name, PVS, like for example, PVS hyphen build. So these kind of labels also you can use. Once you define this label, and you can use this label on your workflow. So for now, I'm using the default one, just not to make things complicated. So and then the other thing is the work folder. So all the jobs um, will like each job if you trigger, like it will create a specific data. So the data will be stored in that underscore work folder. So you can give like the workflow folder name that you want. I'm using underscore work itself. So the settings is saved. The final step is to execute the script, the runner script. So I have executed this like main steps, which is running in the background. So if you go to the GitHub now, and if you just go to runners, see it shows the runner that we just configured. Status is ideal and it has the labels. So let's go into the repository now and just simply run a job. So this is like project which I'll discuss in the upcoming classes. This project is like a Terraform based project where we provision resources using Terraform using the workflow. So this is the workflow that configures all the steps to perform the uh, resource creations. So, and this is like this project will create basically S3 resource on the AWS using Terraform. So I'm primarily focusing on the workflow point of view. So when we should trigger, what happens if you just commit a push? So each like sometimes if you are pushing some commit, we should not deploy the resources directly, which is not a best practice because we have to review the changes first and then deploy the changes. So those kind of configurations that you can do in the GitHub workflows. So all these steps that we do the same step, which I'll explain you separately. But what you need to focus now is the runs. So whenever you define a workflow that runs on self-hosted, like this is the label that I showed you earlier, right? So if you define this label, this job will be executed on the EC2 instance. So earlier, most of the time we use Ubuntu FN latest, which is GitHub hosted runner. So, but that I have changed to self-hosted runner because I want my workflow to run on the EC2 instance. And if you go to actions, go to Terraform GitHub, and then click on run workflow. So I have like, I'm running the workflow from main branch, and then I'm running the Terraform action as plan. So you can use plan or apply, because if you like opted for the apply, the plan will be executed. If some of you know are familiar with the Terraform, so every time you apply any changes, you have to create a first a plan. And then if you can also run destroy directly, where it will destroy the resources, which is like not required for now. I'm just running the plan for now and then clicking on run workflow. So my intention is to run on the workflow on the runner that I created. So it started running. So the Terraform plan is running. So it failed. Let's see the error why it's failed. So it's failed because the EC2 instance runner doesn't have a unzip for unzip software. So let's install that unzip. I mean unzip package. So right now my EC2 instance. So what I'm doing is I'm trying to update the OS and then installing the unzip. And then I'm going to the GitHub. So now the step like there are, I mean, the job is failed at step number 3. So what I'm doing is I'm rerunning the job. Rerun all those. So if you go inside this, so it started, like the runner started picking up the job, and now it is fast. So AWS configure, AWS credentials have already configured, that's why it is able to consume that. So, and then, uh, like here in this demo, I have not used for authenticating to the AWS from the runner. I have used something called actions, I mean, called role. So using role, you can talk to the AWS. So, and then it started executing the run plan. So for the run plan, if you see, scroll down, we were able to, it is able to create, like ready to create 18 resources. And then it shows us the plan, and that's it. It will not basically execute anything. I mean, it will not execute the apply. So with this, right, you can, like, we are able to execute the jobs on the self-hosted runners. And if you can view the workflow file, and if you come here, it basically runs on the self-hosted runner. So the other example which I want to explain is, so right, like the first time I executed the job, it failed because of some software is not installed. So I have installed manually uh, in the EC2 instance, but that is not again best practice, right? So we don't want to touch anything. We want everything to be automated such a way that every time a new EC2 instance is created on the backend, either the EC2 instance will have already something called, if you guys might be aware of AMI, in some projects we call it as AMI baking. Baking in the sense AMI baking. So which we have some organization called as golden image. So what is the concept of golden images? So in AWS, we'll have the AMIs, right? Amazon Mission Image, which is basically a OS image. So we take that image and then we create a EC2 instance out of that image. It is a separate process. It is nothing to do with the runners. I'm just explaining you how the golden image is used in the organizations. So first they'll take the base image from the AWS marketplace, which is a verified one, and then they create a EC2 instance. Then they install all the prerequisites like CrowdStrike, Wallis, like these are like security related tools. Also, they will install like Splunk, and also once they install all these softwares, they'll create and bundle, and then they will create a new AMI. Again, they will create a new AMI. So this AMI is now called as golden AMI because this AMI has all the requests. For example, like in the previous step, I have used manual steps to install the unzip package, right? What if they are installed as part of the process, as part of the golden AMI? So you can directly use the AMI, right? So that if you are using this AMI and you provision a EC2 instance for your self-hosted runners, so the new AMI will have all the required softwares and already available, and you don't have to install these installation steps on your workflow. This is like it takes saves us a lot of time, and then we can use this AMI and then execute the jobs. So industries they follow these standards to like make use of the like any AMIs that require all the prerequisites that they follow this process. So this is one way. The other way is during EC2 provision. Moving EC2 is provision. Once the EC2 is provision, they will call SSM document. The SSM document in AWS will have all the scripts. So as soon as the EC2 instance provision, the EC2 instance will trigger this SSM document, which all the scripts will be available. So these scripts are related to installation of the prerequisites. And also these scripts sometimes includes Ansible playbooks as well. So these playbooks will basically have all the required steps to install the softwares. So this is like during EC2 provision. We do something during AMI baking. So this we call it as golden AMI, and this process we basically call as non-golden AMI process. So ultimate goal is ultimate goal is to have the VM ready with all the prerequisites softwares. So either you can create a AMI or during the AMI baking process. I mean, from the AMIs, once the AMI is picked up, once the AMI is base AMI is picked up, once you create a EC2 instance, so you can trigger the scripts to install all of these softwares, and then you create a new AMI out of this EC2 instance that you can do. That is called as golden AMI. Or we'll first create a base EC2, EC2 instance, and then during the instance provision, trigger the SSM document, and then using like the scripts, Ansible playbooks, you install all the required softwares. So that process is called non-golden AMI. So the current project self-hosted runner that we configured is we deployed the resources. We tried to deploy the resources where we executed Terraform commands as part of the workflow, where we have executed the plan and executed our steps on the self-hosted runners. So these steps, like these entire steps, we'll explain maybe in tomorrow's session. But for now, what you need to focus is just setting up the self-hosted runners. So the other thing I want to show you is the arc. So right now, everything I showed you on the EC2 instance. So there is something called as action runner controller. So it is basically a Kubernetes operator where it will automatically orchestrate and scale self-hosted runners based on the workloads. I mean, if so many teams like to get a workflow, so many developers to get a workflow, this arc will automatically create self-hosted runners automatically, where it will create as a pod that will execute your jobs. So you can, with Arc, there is some concept called runner scale sets, where it basically scale the number of workflows running in our repository automatically. You just go through this document. It has so many concepts related to the org that gives you like a high level understanding of how you can set up the action and controller on the Kubernetes cluster. So it will give a detailed information about the Linux-based Windows, Mac OS, how you can auto scale, how you can configure the runners, how you can install this operator on the EKS. So action and controller is like super powerful. Earlier it was an open source project. Like few years back, GitHub is like they purchased this open source project. They integrated to the GitHub ecosystems. Yeah, I think on today's class, that is what I want to explain you guys. If you have any questions. Hi, Pradeep. I think you joined late, right? Or
Yeah, Surya, I joined it.
okay, I think at least you follow something. Like,
Sorry?
did you follow like?
Yeah, I started something, so I need to see from the starting. I missed something.